Yeah, hello everyone. Good evening. Can you guys hear me? If you can hear me, kindly say something.
Hello, good evening. You're audible from
Good
here.
evening. Yeah, it's a lovely evening. So we are actually starting right now because we have so much to do today. For people that have seen the flyer, we know that we won't be wasting much of our time today, but if you know that you have anybody that's supposed to be here, be your friend, your colleague, that you know that this very session will actually benefit. So kindly let's just give grace of like 2 minutes so that they can quickly join us and also enjoy what we have for today. All right. Yeah. So good evening. Obasoro, Olakunle, Richard, I can see you. Good evening. Good evening, Katik Vama. It's lovely to actually have each and every one of you today. So, uh, welcome once again to this second session of our bi-weekly knowledge series. As we all know, this is CNCF Lagos chapter, where we organize our bi-weekly knowledge series. And if you are here last week, I'm very sure you've learned a lot for the last week's session. And this very week, we have as an amazing session tonight, as you can see on my screen, you know. And yeah, at CNCA, we actually is created to help engineers, as we all know. I want to believe that almost everyone that is here, that we are on the WhatsApp group. That's where we share information. Oh, Kartik, joining from India, nice to be here. Oh, it's really nice to have Kartik joining all the way from India. We're happy to have you around. Thank you for joining us. So, like I'm saying, we is created to help engineers. The CNCF Lagos chapter. Generally, we know that CNCF Cloud Native Compute Foundation is everywhere. Almost all the states in the country where you reside is there. So you can just look for a local chapter that you can actually join. And maybe when you guys are having physical meetup, you can easily learn one or two things. It's for enthusiasts like you, practitioner that where we learn, we connect, and also gain practical experience. And it's with community conversation around cloud native technology. So this very bi-weekly that we are doing the second series today is one of the things we actually do in CNCF Lagos. We do it every month to at least make sure that we connect, we invite industrial experts to join us so that we ensure we keep educating ourselves in the community. We actually do it twice every month. Like we all know, we we come with new topics, and for December, this is the last session for December. All things being equal, by January, we continue. And just for me to introduce myself, my name is Mayowa Fajbe. I'm a DevOps engineer. I'm part of CNCF member, where we make things happen. So the topic before us today, as we all know, is an interesting topic, which I believe almost everybody will be happy to see how, especially the practical session, the demo session is going to work out, because as we all know that official Kubernetes community maintain Ingress NGINX controller is being retired. with the official end of life in March 2026. So I believe that many of us are planning to migrate right now to a new API, which is maybe it might be the gateway API, or for people that want to start using traffic, that we have one of our speakers that we be talking about today. So, without wasting much of our time, I'll be introducing our guests. We have two guests this evening, so that's why I say is actually a power pack session. As we all know, industrial experts. The two of them, in one way or the other, have connected with them for some time now. You know, so this evening, the very first session will be taken by our great man, Peterson Ngoko. Peterson Ngoko is a senior cloud engineer at Andela with over 9 years of experience, has been delivering and supporting production systems across AWS, Azure, and GCP. So he has worked with extensively with Kubernetes, with distributed engineering team to design, deploy, and maintain scalable, secure, and reliable platform with hand-on experience across infrastructure automation, CI/CD, and operational excellence. You can actually connect with Peterson on X. I will be dropping the handle on X as we go, but uh, with round of applause, let's welcome Peterson as he give us today's um, talk demo, because is that demo, I believe we are all interested. But before that demo, I'm very sure he has a lot of things. So let's, with a round of applause on the chat, kindly welcome Peterson. Thank you. Peterson, over to you.
Hi everyone. Good evening. If you're joining from other parts of the world, good afternoon. Good evening still. I think people from India. So today we are going to be talking about Kubernetes.
Okay,
Engineering.
just a minute.
Yeah.
Just a minute, Peterson.
Mhm.
Can you hear me?
Yes, loud and clear, we can hear you.
All right, so I'm just going to be presenting right now. Thank you very much.
Um.
Is that fine?
Yeah. They already got the ability to share, so it's fine. I can do it.
Oh, okay, 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 great. Thank you then.
Mm, this is my thing. Okay. So give me a minute, please. Let me do this guy. Okay. And then I have multiple screens, so I'm trying to share the right one. Um, Tell me when you can see my screen.
Yes, Peterson, we can see your screen.
Right. Thank you very much. Um, okay. So we're talking about Kubernetes, and we're also talking about NGINX. As we all know today, the NGINX Ingress is going out of life, and teams are preparing to um, migrate away from it. And so today we're going to be talking about an option. Um, okay, so trying to open up everything I need to share. Okay, cool. All right. So, might be wondering, my name is Peterson. I'm a senior engineer at Candela, and today I'm going to walking us through, what Gateway API is and how we're involving beyond, regular Ingress. So, Gateway API really is the modern Kubernetes networking API that is designed to replace Ingress over time, right? Solve basic routing such as but as Kubernetes environments grew, especially in enterprises, most times it becomes difficult to manage, right? And Gateway API is not just a single object; it is a family of APIs that standardize how traffic enters into a Kubernetes cluster. The key idea here is to provide that it provides advanced routing capabilities while maintaining portability across different implementations like traffic, Envoy, Istio, or Kong. They all have their implementation of Gateway API. So instead of being tied to like NGINX annotations um, in your YAML files, right? Having specific vendor logins would have a clean Kubernetes native way to describe traffic behavior. One of the biggest problems with Ingress really was is that everything lives in a single YAML file. So infrastructure configuration, TLS, routing rules and application logic are all mixed together, right? Um, in real organizations, that doesn't really scale. Infrastructure teams, platform teams, and application teams, they all have their own, separate responsibilities. And Gateway API was introduced to fix this by separating concerns cleanly, allowing different teams to own different parts of the traffic management, and removing the dependency from one controller specific annotation. And this makes Kubernetes networking easier to reason about and more secure and also more scalable. Um, so this slide is an important one because it's very good for us to understand the concept of Gateway API. So Gateway API is designed around real organizational rules. Um, I'm going to show a diagram later from the official documentation of Gateway API. So the infrastructure providers define the gateway class. This gateway class is cluster scoped and answers the question like what implementation are we using? For example, different implementation exists such as traffic, Envoy, Istio, or like a cloud load balancer, right? Then cluster operators manage gateways. Gateways define how traffic enter into the cluster, the ports, the protocols, TLS, which routes are allowed. Then application developers only work with the routes. So pretty much they will define the host name, paths, rewrites, and headers, without worrying about the TLS or load balancers. And then we have RBAC as rule-based access control, which naturally enforces this separation, and which is why Gateway, API fits enterprise environments well. So I'm trying to go to their website. Gateway API. Okay. So let me see. Am I sharing the entire screen? I don't think I am. Share window. Entire screen. Screen one, screen two, screen one. Share. Okay. So as we can see here, right, the infrastructure and providers, they provide the gateway class that is, like I said, the implementation that is being used. Cluster operators, they provide the gateway. Application developers, handle the routing, to each service, TLS routes to each service, but they do not, worry about TLS per se. So that is that on this. Um, the next thing we'll be talking about is the demo architecture. So I'll be moving straight to a demo. So what we're going to be defining really is we're going to be creating a simple Kubernetes cluster using kind. Everything is kept simple and local. We are going to be installing a gateway API, the gateway API CRDs using the experimental channel so that we can see more features. And then we're also going to deploy a gateway API controller. In this case, we're going to be using traffic, but nothing is in this demo really is traffic specific. So it's just give you an idea of how gateway API is implemented. And then we're also going to deploy a Go microservice, Python microservice, and a simple, web front end. And since we are running all of this locally for DNS, I'm going to use /etc/host to simulate DNS, and then use kubectl port forward really. So let's get straight into it. All right. So I already have some code that I've written up before. I'm just going to be walking you guys through what I'm doing, right? As I'm doing it. So like I said, first we're going to create a Kubernetes cluster using kind. If you're on Mac OS, it's simple as saying brew install kind and then running this kind create cluster, right? So let's wait for that to run. So as it's doing that, it's creating the nodes and everything we need for a simple testing environment, right? So wait for that to finish. Right, so that's done. Next thing we would want to do, like I said earlier too, was we are going to install if you remember here, I said we are going to install the gateway API CRD experimental channel, right? So that's the next thing we're going to do here. So we're just applying from the gateway API experimental channel. I might be going too fast, so thing is, this is more of for people that may have more experience with Kubernetes and are looking to shift away from Ingress. It's not really beginner friendly to make it easier to understand. So what it has done here really is just installed
Um,
all of.
Excuse me, Pizzin.
Hmm?
Please, can you zoom in into your screen? It's a little bit too tiny for us to see. Thank you.
Okay, give me a minute. How about now? Is it better?
Yes, that's better. Thank you.
All right. So the next thing, what it's doing really is installing the gate passes, the gateway, the HTTP routes from the experimental channel, right? And then what we want to do too is install the Python and Golang applications that I have created earlier, really. So they all live under these parts. I'm not going to bore you by looking through it, but just know that it's a Python and Golang application. It's just a simple one, really. So that created that, and then I want to get to the parts for you know. Okay, so I've deployed the three applications I need. So let's start from beginning. Let's run kubectl commands to see if everything is actually running. Nodes is running, and kubectl get pods. Web app is still creating. Okay, it's running now. So we need the test domains. Initially, when I'm testing, I know I've already created this, but for demo purposes, let's show you how we are simulating. Sorry. Right. So pretty much this would route example.com to your local hosts, and same thing with all of these other URLs just to simulate a domain, right? So let's exit out of this. All right. Um, Next thing we would want to do from the demo is what install the traffic gateway API controller. All right. So to do that, we are going to be running. I'm pegging a particular traffic version 3.6.0, and I'm also adding the um, repo to my Helm and updating the repo, and then looking for the version. So let's see. Once I paste all of this in here, let's see what happens. Okay, so it says it already exists because I've run this before. Then it's getting, other repositories that I have for Helm. Okay, so I'll wait for that to run. Okay, it's complete. That's good. So you can see, shows us all the versions that traffic has, right? Then what we are going to do is we're now going to use that chat version and use Helm install to install that um, particular version of traffic API controller. Okay, so it deployed, but then let's check the pods really, right, to see if there's any issues. Still creating. Wait for it to finish. Okay. All right. So it's running now. I want to check the logs for traffic itself, for the traffic container instance. Okay. All right. So we see it started everything. The gateway provider, the CRD, and everything started it successfully. So one thing we're going to do is we are going to port forward traffic to port 80, and so that traffic can successfully receive HTTP traffic, locally. So we can simulate that. So I'm going to open another terminal. I'm going to run that there and leave it open. Okay. My computer requires I do this in administrator mode. Okay. So it's running, listening on port 80. All right. So let's look at the next slide. Okay, before we do that, let's actually install the gateway class and the gateway itself, right? So to enable traffic from the gateway class, we need to enable traffic for those apps that we created. We need to install the gateway class. Gateway class, like I said earlier, is a cluster resource and is defined by the infrastructure and provider. So we are going to be using traffic gateway class YAML, which I have locally. If I can find it, I have a simple one that just defines the gateway class and then the controller name, really, right? So we're going to be installing this. Right, so we created the class. We want to check if there's anything wrong with it. It's accepted, you can see. Then we want to describe the gateway class too. Okay. So we see that everything is accepted through, there's no events or issues, right? And the next thing we want to do is also install the gateway. I can show you what it is. So we are installing the kind gateway class name, we're defining it as traffic, and then we are defining different routes and listeners. So basically what this is trying to do or tell us is, okay, allow HTTP routes all from the same namespace, right? If you change this to all, we are saying, okay, allow traffic from all namespaces on port 80 for this route. But this would allow only, try to tie down the gateway class or the gateway to that particular, to listen from a particular namespace, right? And we are also using another route that is for HTTPS. So let's see what happens when we run this. So it's created, and then I want to describe the gateway itself. So as you can see, it has two listeners, right? So one of them passed and then the other one failed because it needs a TLS secret for HTTPS. So we'll get back to this, but then let's move forward. For now, let's see the different features of traffic, the HTTP routing, and different power that API gateway can give us. So that moves me to the next slide. Pretty much using HTTP routes, we can route traffic by host name, just like any traditional ingress. We can route it by path. We can write it by URL rewrite so that multiple services can share a particular domain. So if you have like two different services that share a domain and like different slash endpoints, right? We can use URL rewrite to help with that. We can also modify the request and response headers. That would help to, like, for cores, as cloud or DevOps engineers, most times, even as back-end, front-end engineers, we are used to seeing cores error. That's cross origin. I will also demonstrate how that works in gateway API, and then we'll see all of these features and understand how easy it is to use, really. So the first thing we want to look at is defining by host name, right? So that means this host name wants it to point to the upstream service of the Python service, and then this one wanted to point to the upstream service of the Golang service. So let's look at the HTTP route by host name YAML file. So what this does really is we are defining the kind to be HTTP routes. So again, for Ingress, when you want to do any type of HTTP route manipulation, the kind has to be HTTP route. And we are saying, okay, allow us to bind to specifically line the gateway, which is the HTTP gateway, HTTP listener. And then we are defining the host name, right, to be this. And we are also defining the backend service, which is the Python service, right? Same thing too for the Go backend, right? So if we run this, if we run this, it creates the two routes. So technically, if we go to this guy, right, as you can see, we are getting a hit from the Python server. Same thing too if we go for the Go application, we're getting a hit. And this is all possible because of the local hosts, DNS that we set up, as well as our gateway that is tying the DNS hostname to our backend services. So that is how I let's where is the yeah by hostname. So it's just pretty much your URL pointing to your backend server. So the next one we want to look at is your routing by path. So for example, we have two types of path that we can use um, for Kubernetes Gateway API. There's exact matching, and then there is a path prefix. So exact matching will mean, okay, so all of this to the end of slash will route. Anything after slash will not, get moved up to the gateway API. And then when we say path prefix, it allows, everything under, like saying after the slash, to be passed on to your upstream Kubernetes server, right? So this is especially useful so that because in real world situations, we want to know where the error is coming from. Because if we hit a 404, we want to know if it's coming from the, your gateway API or it's coming from your server, your service, right? So for example, what we are going to do now is we're going to look at the path by exact match. So here we have the exact matching and we are saying, okay, match this host name exactly, right? And the value is this. So anything after this will not work. Same thing too with the gateway API for the Go and backend, right? So let's run this. Let's see what happens. It's always good to show what I mean. All right. So if I go here, it will tell me hello from Python, right? Same thing too if I go here. Now my Go backend has a status page, right? So if I put the status page with the exact, what happens? It tells me for page found, right? Now let's see what happens when I use the other type of routing, path prefix. So I'm just going to comment this out and uncomment, save that, then rerun, and then go back to my Go app, right? And then I do slash status. Let's see what happens. We see now it's passing it over to the Go server. So it's particularly useful when you have, like sub pages and all. You want to be sure what type of HTTP route you are using, right? Or the routing type you are using. We do not want to paths match exactly, and then it will not get passed on to your backend server, really. So that's just a simple demo of that. Then the next one really will be routing using URL rewrite. We can rewrite the host name or URL, and in this way we can combine the two services under a single domain. So if you notice, these two are two different domains, right? So but what if we have a domain exampleapp.com and we want to, use different parts at the end to route to the different backend services? How do we do that? So let's look at the next YAML file that we have as an example. So what we are doing is pretty much almost the same thing with same kind HTTP route, but here we are saying, okay, match the type, right? Match the path http dot example app.com. The type will be path prefix because obviously we want to pass some other things. But now the value will be no longer slash, but then slash API slash Python. So basically it's telling us that, okay, once it sees this endpoint, right, match it and do a URL to the base of the home page and then match it to the backend server home, like default home page. That's pretty much what it's doing here. It's the same thing too with the Go server. So let's run that and let's see what happens. All right, so that got applied successfully. So if I go to example.com/api/python, I should get routed to my Python service. So yes. And then for the Go service too, yes. But then if I also want to go to the status page, I have to put the entire thing /status, right? And take me to my status page. So that's how we can put multiple services under the same domain, but then with different paths, and then routing it to different backend services, right? So with cores, we want to see, obviously, if we have two different origins that want to make requests to each other, will get hit by cores in the browser, right? So we want to see a way we can manage that. I know that in the coming days, I don't know if it's there yet. I haven't really checked, but I know that in coming days they are trying to bring out, like, default cores manipulation and everything. But this is a way we can do that right now with response and request header manipulation. So we are first going to put forward. This is for the web application that we have, that we are using for cores. So all right, so that's running. So what happens is I would want to go to my local host port 8000. Uh, all right. Okay. So as you can see, I made a request to my Go backend server, my web app, and it's with core 0, because localhost 8000 is trying to make a request to example app.app/go or whatever, right? So we can see that in the inspect page. If you go to the console page, we can see that this is blocked by cause policy and all of that. So how do we fix this? If you go back to our editor, we can look at the HTTP routes by modifying. So what we are doing here is, okay, look at this host name, right? Anything that is coming into there, modify the response, and we can add or remove, right? But in this case, we are adding. So we are going to add a custom header, allow which access, access control, allow origin, and then the different methods and all of that, so that we can, bypass calls. In that case, let's run this and then let's see what happens. Okay, so let's see, where is my, okay, so didn't work. We are using 127 or 0. So this is one thing too we need to think about, right? In testing or wherever, if you use 127 in your YAML file, the value that we allowed was localhost, not 127. So if we do this, it will still, but what we need to do is, because localhost 127, so if we do this, right, and then we make a cause request, it allows it no cause error, because we've already added or manipulated that header. So if we check the networking tab, and then we do, let me see if I can find it, the headers, you can see all of the access control stuff that we added, right? They're all present, and this is coming from the gateway API. So that's how we can manipulate cores using gateway API, right? And we have seen from each of the different methods as to how, you know, we can use HTTP routes to route by hostname, by path, URL rewrites, header manipulation, and then weighted backends. Okay, I did not really touch on weighted backends, so that's pretty much. If you look at all of these, right, we can see the weight here. We can specify, if you have like multiple instances of the same backend or something, we can specify the weight at which you want the request to hit that particular backend, right? Um, yeah, so that's pretty much this. The next thing we want to look at is TLS. That is one major improvement that Gateway API is how it handles like its TLS, right? TLS is configured at the gateway level, not per application. So certificates live as Kubernetes secrets and can be centrally managed and rotated. And this means that application services stay simple and they only speak HTTP while the gateway handles all the encryption and everything, right? To summarize, it brings clarity and structure to Kubernetes networking, and it aligns with real world problems and team boundaries really. So it separates what each team is supposed to be responsible for. It's portable across like um, different implementations like Traffic, Envoy, Istio, and it is the long term direction of Kubernetes traffic management. So let's see is use make cert. So a simple um, way to get locally trusted certificates and does not require any configuration. So this is a way to download it if you're on Linux, but then if you're on Windows, if you're on Mac, you can just say brew install, make cert and it work. And then, so what we can do here now is run this second one since I already have Mixert installed, right? So it does the export of the variable, and then we are trying to just create a certificate, for example, .com. So in a production environment, really, right, we are going to be using something like cert manager to secrets, and yeah, it still works the same way normally with your Kubernetes Ingress, right? Then next thing we want to do is make cert install. Did I copy the right thing? No. Okay, so I'd run this before, so it's already saying that it's already installed and the system trusts everything, right? One thing I want to do is create. It's looking for this, right? So we want to create it using the generated certificate that it did. So it has created the secret. Now, if we check that gateway again, we shouldn't be having that issue. So it has seen the secrets and um, both of the routes are attached, and there are no errors right to the gateway. So both is listening to both HTTP and HTTPS. So we have already, if you check the HTTP routes by TLS, right? So what we are trying to HTTP on the same kind of gateway, and then to our Go server, right? We are only doing it for the Go server. So we first want to apply this. So that updates the Go route to be able to, get HTTPS. And then we want to port forward. So what we can do is open another tab and then port forward 443. Okay, so I need to sudo and then Now we're listening on 443, right? So if we go to this, we should see, HTTPS. And then if we are checking the certificates, I would have to, yeah. So I'd have to, let me check the, yeah. So we can see it's secure using certs and the local everything, right? So it's using the local certs to validate HTTPS and will not get HTTPS errors, right? Yeah. So that's pretty much it on Gateway API. I know it's a lot to handle, but if you're familiar with NGINX Ingress, it should not be too um, like another thing entirely, right? It should be something that is somewhat familiar to us with NGINX Ingress. It's a more standardized way we are doing it now, and it's fairly easy to migrate different, implementation providers. Like, for example, I know we have Traffic on Call. They'll be showing their implementation and other things so the traffic can do. And then there are other ones too, right? There are other implementations like Envoy, Istio, Kong. They all have their demo and their documentations. So it's just for you to, I mean, even like I know Microsoft and the rest will also be bringing out their own cloud native and Google and AWS for Gateway API. So this here just showcases the power of Gateway API, how to route, different examples on how to route, and then how to use HTTPS for your different routes. Um, yeah, so key takeaway really is the way to route is using the kind HTTP route for all your manifests, right? Attaching it to your gateway kind. Um, in these few minutes. Yeah. Okay, so I'm seeing the chats. Should I go on with the answering of the questions, or how are we doing this?
Okay. All right. Can you hear me?
Yes, yes.
All right. Thank you so much. For that session, Peterson. We're going to take the questions, right? But that's going to come after the topic segment, so that we can keep everything in order and in line. So don't worry, Katik Vamar. I hope I pronounced your name properly. We're going to take your questions, but just for now, we want to invite Tofik to the stage. So thank you so much, Peterson, for this amazing section, and it's been an amazing one. Thank you. So I'm going to be handing over to Mayora now. All right. It seems like Mayora is having a technical issue, so I'm just going to go ahead and invite Eric to the stage. All right. Please let me know when you can see my screen. All right. Is it up? Sure. Please let me know if you can see my screen. Hello.
Yes, we can see it.
All right, thank you very much. All right, so we're going to be having Sudik Goswami, which happens to be the CEO and president of Traffic Labs, right? With over 27 years career spanning through multiple engineering, product, and executive discipline. Sudeep is now leading the shift towards cloud native and GitHub driven API management as the CEO of Traffic Lab. And today is going to be giving us, you know, insight into how we're going to be managing the Ingress engines depreciation with practical migration strategies for all Kubernetes teams. So over to you, Sudeep. Thank you for joining us today.
Thank you. Thank you for having me. If you can stop sharing, then I'll share my screen.
Yeah, thank you.
Perfect. Hello, everyone. Thank you for joining. So I think, Peterson, thank you for doing a great job of demoing traffic. So what I want to share with you is essentially some practical strategies on how you should think about migrating from Ingress NGINX to, um, you know, to something else. And I think traffic would be a great place. What Peterson talked about was really focused on Gateway API, and we will touch on that. But I also want to make sure that you guys have options here. There are many, many use cases for which migrating to Gateway API may not be the most logical next step. And you may need to migrate to traffic's implementation and then migrate to Gateway API. So we'll walk you through some strategies. It's not going to be the same use case for everybody, but our perspective on this, it comes from day two operations perspective, because you're seeing like many vendors that are essentially saying move to our controller, move to our controller. All of them, what they're assuming is that you will discard every configuration that you have done with Ingress NGINX, and you will start from scratch with the new controller. Sounds, sounds very unrealistic. If you have a very simple configuration, sure, you can do that. But the clients that we deal with, they are enterprise clients. They have tens and hundreds, some have even thousands of installations of Ingress NGINX, and they have hundreds of annotations. That approach just doesn't work. And that's really going to be the focus of this presentation. So one thing for you all to be aware of, we are the only drop-in replacement for Ingress NGINX today. And I'll walk you through why that is the case. Yes, we are the only drop-in replacement. And drop-in does not mean get rid of your Ingress NGINX annotations. Drop-in means keep your Ingress NGINX annotations and then bring in traffic, do the cutover, and then get rid of Ingress NGINX. That is the approach. Now, obviously, that will require a lot of effort on our side, on the community's part to collaborate with us. But this is the mission that we are on. So let's start with this. One thing I want to share with you, our founder and CEO, we just did a webinar, I think 2 days ago on Wednesday. It is available on our website. The link is here. It is on YouTube as well. It will go into a lot more detail than I'm going to be able to provide here on this call. So if you want more specific details, please watch this webinar. It is freely available on our website. Now, with that said, let's jump in. I don't need to introduce you to traffic. I think Peterson already did a great job of that. One thing I want to emphasize here is we have a very robust portfolio of capabilities, starting with open source. This is really the focus of today's discussion. which is an application proxy, or think of this as an ingress controller. There are many names for the same thing. This is the open source, but what we also have, as the needs are more than what an open source application proxy can provide, we have additional capabilities that we offer through our paid tiers. The next logical tier after the application proxy is an API gateway. And we have also packaged in an AI gateway and an MCP gateway in that same binary. And then beyond that, if API management becomes a key requirement, this is where you have API lifecycle management. You need a developer portal. You are doing API versioning. You need to do API-based rate limiting, API-based quota management, all of those things where you need the API management layer. And what we have done from a portfolio standpoint, as you go from the left to the right, to go from step 1 to step 2, it is one Helm chart install. It takes 30 seconds, and it does an in-place binary upgrade with the license key, and it gives you all of this, and it preserves the configuration that you have done in the application proxy. And the same thing from 2 to 3, you run another Helm chart install command. In this case, there is no binary change. It's the same binary, and just through a licensing, you get additional capabilities. So again, very day 2 ops friendly. So as people are moving from Ingress NGINX to traffic as the Ingress, that is not the end destination. That is just a step 1, because then that exposes them to all of these other capabilities that they could have over time, depending on their use case. So this is the big vision and the big portfolio strategy. Now, let's dig into Ingress NGINX. I already mentioned this. We are the only drop-in replacement. And what we have done here to make this possible is, first, this approach. We need to, what we are calling the step 1, which is stop the bleeding first, and then you can modernize. So you need to stabilize and then modernize. Stabilizing means you only have less than 100 days to migrate before everything is cut off. So if you want to maximize the chances of a great migration, you need to find something that provides all of or most of the annotation support. And traffic can be that provider that can give you that. And then as Gateway API evolves, is still an evolving standard, then you start to plan your migration accordingly to Gateway API, which requires a full modernization. As Peterson shared earlier, the Gateway API architecture separates concerns. So it's not the same one-for-one replacement from your Ingress. You have to think about new objects, new concepts. So it requires a lot more architectural work for you to prepare yourself to move to Gateway API. So the first thing, there's 3 phases here. Level 1, how do you move quickly? You need to audit your environment. Then you need to decommission your Ingress NGINX. And then third could be the Gateway API, which is really the end game here for many, many users. So on the first one, we have made life a little simpler here. How do you quickly assess your migration complexity? So we have come up with an Ingress NGINX migration tool. And I'm going to walk you through. So first of all, actually, what you see is we have created a new website. It's called ingressinginxmigration.org. I think Dylan on our team can maybe put the link on the chat window. In here, you will get the full guide. So here we're showing you a command that quickly checks for what kind of Ingress or what kind of annotations do you already have supported. So you run this command, and immediately you're going to get a list of all the annotations. Now, here comes the NGINX migration tool. It's on GitHub. It's open sourced. You run this tool. it is actually going to log into your cluster, your environment, once you give it access to it. And then it is going to auto-generate a report.
Just a minute, please. Can you increase this size? It's a little bit tiny.
I'm going to try. This is a recorded video, so I'm not sure if that can
Yeah,
be
it's
increased.
better now. It's better.
Is better now? Okay. So
Yes. Thank you.
let me make it bigger. Is this better?
Yes, yes, yes. Thank you.
Okay. All right. So let me just go back real quick. So what this is doing, it's running the tool, is connecting to your cluster, is discovering everything, and then it is going to generate a report at the end. So if you just let it run, what it's going to do is compute everything, and there we go. This is the report, and in this case, you're in luck. All of the Ingress resources are compatible with traffic. Now, this is not going to be most of the case, right? Like I wish there was the case, but there will be more scenarios. So here we're just custom creating one. We're just going to change an annotation and run it again. And now you will see in this report, this is probably more realistic on what you're going to see. So let me just pause this. This is what you're going to see. A set of unsupported ingresses that needs more work for you to migrate over. And if you share this report with traffic, then we can work together and prioritize what are the annotations that we need to work on supporting. So this is step one. Now, level two. This is going to be the most, one of the key parts to the strategy here is, okay, you've discovered all the annotations, and now you're going to be in this zone where not all annotations are going to be supported by traffic. Some will be. So you need to ensure that both Ingress NGINX and traffic can coexist. And this is a very practical approach and a very practical use case. And I think this is probably going to be the de facto use case for many, many people. And for that, what we have done, we have created a dedicated Kubernetes Ingress NGINX provider. It is going to be installed in the same, you can install this in the same cluster. It is going to parse all of your existing Kubernetes or Ingress NGINX annotations, let's say. It will translate the ones that it can into traffic objects, traffic CRDs. And then, this is just a quick list. I mean, we have 29. Maybe this list has already grown now since the last time we put these slides together. So we're actively adding more and more annotation support here. But this is probably the, like a semi-updated list. And then this is the heart of the strategy, where step one, you are installing traffic side by side. So in the same Kubernetes cluster, you have traffic running, you have Ingress NGINX, sorry. Then through DNS, you are now able to control what traffic goes to NGINX, what traffic actually goes to traffic. And this is where this coexistence, step two is critical here, because now the coexistence of both is absolutely critical. And then eventually you can decommission Ingress NGINX once all of the annotations have been moved over. We have also documented this on our website. And Dylan, if you can send this link as well to the team. This is on our docs page. This walks through the full migration plan. And what you will see here, this is what I'm describing through the image, where you have the coexistence of NGINX and traffic, and through DNS and through load balancing, you're going to be able to control both of this. All right, so now the final picture, and I think I'm not going to spend too much time on this because Peterson has already done a great job of showing you what can be done today. If you wanted to move to Traffic's Gateway API implementation, absolutely, go for it. We have been active in the Gateway API community since the beginning. Since it was even officially, before it was even officially called Gateway API. We have been involved and we have been very active. We support the latest 1.4 version of Gateway API, and we expect to continue driving and working closely with the standard and being a leader in supporting this. Having said that, we don't think Gateway API is ready right now for the most of the Ingress NGINX use cases. And here are some simple reasons, and there's many more than this. Some of the key features are still experimental. And here's just a sample of them. MTLS with backend servers, stickiness, CORS, HTTP route retries, observability. Like when somebody's deploying this in production, these things matter. And here's another view of it. Like there's 136 Ingress NGINX annotations that are not supported today. And if you look at the red, 43% of them have no plans. So based on the current roadmap that we see of the Gateway API, there are no plans to migrate these just yet. And now I understand this is a moving target, but this is the current reality. This is what makes it impractical to say, move everything to Gateway API. And that's why you need a more pragmatic approach. And that is really what we are providing, is think of us as a bridge from Ingress NGINX to Gateway API. We don't know how long it's going to take for the Gateway API standard to get to a point where it can handle most of them. It's a community. It's driven by a lot of people. We at Traffic do not control the outcome. We are going to be a participant in it. We'll obviously be one of the leading participants in it, but we don't control that outcome. And therefore, there is a strong need for someone like Traffic to bridge the gap. And that's what we're providing here. So that's pretty much it. I want to mention one thing. We're also one of the only providers in this space that provide enterprise support on our open source. And this could be one way for you or your customers to partner with us. We will continue to support these annotations, add support for these annotations, put them in the open source binary. But you may want support because many of your customers, and you may be one of them yourself, would need to have a great migration path to go from where you are today to the end state. And that's going to require active partnering. Maybe like some of the things that just cannot be migrated, for example, snippets support. There is no one-for-one equivalent. So the snippets, in order to support that on Traffic or wherever, you will need to re-architect some of those things. So you need a partner on this journey. And that's what Traffic is able to provide. And that's why we have an enterprise support. And if you go to our website, I'll just show you. If you go to traffic.io and you go to OSS support, this kind of gives you a flavor for what we provide along with our support. This is really a partnership. And this, I think this table kind of sums it all up. You will get prioritized CVE fixes. You're obviously going to be able to partner with us so we can guide you on the best path to migrate. We can also help prioritize some of the annotations, and especially for things that don't have great one-for-one, we'll work with you to give you a better path. And I think that's pretty much it. Maybe a couple other things I want to mention. This is the website. I think you probably already have the link to this. And if you go down this is where the link to the migration tool is. If you click this, It will take you to the GitHub page. And this is where you can kind of run the report that I was showing you. Our CTO has also written a great blog, so you can actually read this. This will give you more insight into the approach that we're taking. And this also has linked to the migration tool. And last thing I would say is, please give us feedback, because none of this will be possible without active collaboration with the community. So if you can give us the feedback on what annotations are more important, and we help you create that, with the reports and with the other assessment tool that we have. But if we have the feedback on, here are the 80% of the annotations that really matter, that's going to help us prioritize more effectively. And that's all I have for today. Thank you for your time. And again, thank you for the community for inviting us to speak here with you.
You are welcome, highly welcome, Sudhi. You're highly welcome. What a fantastic session. Thank you so much. Peterson as well, we really appreciate you. So there are some questions that the audience are actually asked. I don't know, is Peterson still here? Peterson, still have you here? Because I believe these
Yes.
are. Oh, okay. Thank you for staying by. So let's quickly go to one question why you are actually giving us that lovely demo. So that someone was like, if the example you are okay, I'm trying to okay, just for clarity, is traffic controller intercepting a request and using a rules mentioned in HTTP route to route traffic? I don't know your comments on that quickly. Thank you. Quick
Um,
comment.
yes. Your simple answer to that is yes. The traffic controller sits in front of any traffic coming into your cluster.
Hello. Please, can anyone confirm if they can hear me?
Yeah, I
Because it
can hear
looks like
you.
the
I
network.
think it's yeah. I think
Yeah, I think
Peterson's
Peterson is
network.
having
Yeah,
network issues. Okay.
Yeah.
network issue. Okay, so
Yeah, he's back.
for okay, I
Hello?
think it's back.
Okay. Did you
Hello,
hear me?
Peterson. We lost you a bit. Yeah.
Oh, okay. Yeah. So I was saying that the simple answer to the question is yes. That it sits in front of your cluster for any traffic, and looks at the rules and everything you defined and points it to the right backend server. For how traffic does that, I would leave that to be answered by Sudeep. So, I mean, but yeah, pretty
All
much
right.
the answer.
All right. Thank you so much. Definitely, I think we have it. So, Sudip, do you have any contribution to that question, or
Yeah, I
would I
mean,
say
what I would
clarification?
say
Yeah.
is, I mean, simply this is how routing works for traffic. Like, whether it's a HTTP route, whether it's an ingress route. I mean, this is the core functionality of traffic, which is it's intercepting the request. So, you configure what's called an entry point in traffic.
Mm-hmm.
You're intercepting the request and you're routing it to the backend. And what traffic is really good at, and uniquely good at, is auto discovering the backend.
Yeah.
So it is able to route the traffic. The HTTP route and ingress route, those are just another interface. And this is what we're trying to do is traffic CRD is ingress route, and gateway API is going to be HTTP route, right? So to the user, it shouldn't matter like which one you use, because what they care about is that the traffic is sending the request to the backend.
Mm-hmm.
All right.
Yeah.
All right. Thank you so much. Thank you so much, Peterson. Thank you so much, Sudip. So quick one now. When Sudip, you actually mentioned this is part of the question I believe our audience does for, or I still want to ask that for organization with custom NGINX snippets, you know, I'd love to know the realistic migration paths that exists without actually sacrificing functionality. But you made us to know that, you know, is kind of a complex one that majority of people that have the custom one we need you know, the technical, your technical support for that. But I don't know if you have, you know, just for them not to the realistic migration paths that exist without them sacrifice. Is there any advice or any guide you can give to people that have the custom engineer snippets?
Yeah, unfortunately, there is no standard um, conversion path for the snippets. I think this is where we need to, and it doesn't matter if it's a traffic they're moving to or something else that they're moving to, they would have to rethink. I mean, snippet is, think of that as like a custom code, custom script that is running, right? I mean, that's maybe a good way to think about that. Whatever that snippet is doing, we need to figure out how to be able to do it in the traffic way of doing things, right? So this is where we need to have a discussion with the client. We need to understand the use case, because the snippet is not just being used in isolation. The snippet is being used with all of the other annotations. So together it forms a business logic. So we need to understand that business logic, and then we can guide them towards what is the best alternative implementation of that.
Okay, thank you so much. Another question I love to ask is, you know, when it comes to the almost everything we do, security is important as well. So, I would like, when it comes to security, what ingress level controls should team prioritize during migration? You know, such as TLS termination, MTLS, rate limiting, or WAF, and how does traffic actually support all of this?
Yeah, great question. So we have seen different implementations of this from, so I'll talk about it from two angles, right? One is what can traffic technically do, and what we are seeing like from our other customers or clients that are wanting to replace Ingress NGINX. So let's start with the second one. What we are seeing from clients that are trying to replace NGINX is, number one is TLS termination, because that's how they have been using Ingress NGINX for TLS termination. And in many cases, we're seeing a WAF. Those are the two things that are being used. And then all of the other things like rate limiting and authentication and authorization, they're pushing it to the next layer in the network. You know, this is one implementation. It's not the only example, but this is one. We are seeing other sets of clients where they were doing TLS termination, a WAF, even authentication, authorization, and rate limiting at the ingress level. The good news is if you replace it with traffic, you can do anything you want with that. You should be able to TLS, obviously. WAF, we have two different implementations of WAF. We have the one in open source, which goes through the WASM interface. And we have the one in our paid tier, which is native Go, integrated directly into the native code of traffic, which is written in Go. The difference between the two is performance. When you go through a WASM interface, there's always a performance hit. So if the performance is a big concern, then you would want to go with the paid traffic tier. And then when it comes to authentication authorization, you know, we support some, you know, we have a full community plugin. Through that, you can support the auth N, auth Z. You can use forward auth. But then if you're looking for something really more robust, then in our paid tier, we have authentication, authorization, OIDC support, and all of the standard protocols.
So much, Sadiq, for that awesome. So, Captain like to know is asking that is there a list of annotations that are current that traffic currently supported? So you just want to know something you
Yep.
can where
We
it
have
is.
already responded on that. If you look
Okay.
on the chat window, Dylan from our
Oh,
side has
okay. The
already
link.
responded to
Oh, awesome, 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 awesome. So, Kartik, I believe you can get answers to that one over there. With Ingress engineers actually, that as we all know, that is approaching the retired end of life. So, what risk should team be most concerned about if they delay migrating too long? Just advice to the as we have in the house for people that are procrastinating. Maybe I'm going to do it early next year. Why should they start migration like now?
Yeah, you're asking me that question?
Yes, maybe just at least just the risk
Sure. I
they
can,
might likely face. So just let them be aware.
yeah, I can give you my perspective. Number one is after the end of March, there will not be any bug fixes. There will not be any CVE fixes. So if there is a vulnerability that comes out and it's a serious one, what do you do? Right? That's going to be a very, very big problem. To me, that's probably the number one problem because let's just say, like, if you have a very simple Ingress NGINX deployment, don't have a lot of annotations, you can probably keep running it. I mean, there's obviously risk, but maybe you can just keep running that. So from a configuration standpoint, you don't have to move right away. But from a security standpoint, regardless of whether your annotations are a small list or a big list, if there is a CVE that affects the entire Ingress NGINX code base, like what happened when, I don't know if you remember, Wiz, the Ingress nightmare that hashtag that became popular a few months ago, almost 6, 7 months ago. I mean, that was a major vulnerability. So something like that happens again, every Ingress NGINX deployment will be at risk from a security standpoint. And that is precisely the reason we think everybody should start planning.
All right. Yeah, thank you so much. Yasin, I don't know, maybe you have any perspective also based on that. Actually, deep as answer, or maybe you have a contribution you just want to make before we round up. Peterson.
Yeah, just adding to what Sudip said, pretty much it's all from a security standpoint, right? It's the same reason why you would want to update your Kubernetes clusters when a Kubernetes version is getting to end of life. You could technically keep running that cluster, but then you give yourself the opportunity to be vulnerable in terms of security. Like patches that have come up, you will not be able to be applied into your cluster if you do not update. The same thing with Ingress and NGINX and retirement. You can technically keep running it, but then if something or if a hacker somewhere develops something that break down the next in some way, there's nobody to patch it up, and then you're left unstuck with that. So that's pretty much it.
Yeah, thank you so much. Engineers in the house. So for you, this is actually the best time for you to start the migration. You don't need to wait till when hackers will just be looking for the back door to enter into uh, your product. So thank you so much, Peter. Thank you so much. Any audience, if you have any question, the floor is actually now. Maybe you have any question for Sudip, you have any question for Peterson, you can right now and ask them directly. If you can't type, because I actually see any question in the Q and A. So if you have any question, our time is fast spent. We are running up some. Anybody? anybody. Uh, thank you very much. I will be rounding up to our director for vote of thanks and the inclusion on this very session. So,
Oh, yes, I can hear
Sophia,
you. Thank you, Mayora.
all right.
Can you hear me?
Yes, loud and clear.
Hello, please
Loud and
confirm
clear.
if you can hear me. All right. Thank you very much. Thank you so much, Mayowa, for coordinating this session. And I want to say a big thank you to Peterson. Oh, you did amazingly well with your session, and I could see a lot of demonstrations, right? Practical demonstration that engineers can begin to implement that is going to help them with their migration journey. And to Sudeep, we say thank you so much. Like, I am so excited for what you're doing in this space, given the fact that you're the first, right? It's actually amazing, amazing. And thank you so much for honoring us today and joining us for this session, right? So guys, this is it from us. We're very excited, and we thank you so much for joining us in this session. Please don't forget to follow Sudeep and Peterson. They share a lot of amazing content, right? In the cloud native space in general, as well as other important topics that is going to be very useful to you as an engineer, whether you're a DevOps engineer or an SR engineer. Okay, I think we have a question. I'll definitely try to do a. Oh, okay. All right. So, Sudeep, I think this question goes to you. So, someone says, I'll definitely try and do a POC on Gateway API in the new year. If I face any issues, where do I share the issues related to traffic?
Yes, I was just typing a response to that. So what I would say, Karthik, we have the Ingress NGINX, the migration repo. You can pretty much if you have some specific, even if you want to submit a PR, you can do that, or you can get in touch with us through that, or we have a community website. You can go to community.traffic.io and you can engage us there. And lastly, you can always reach out to me on LinkedIn.
Okay. Thank you so much, Sudeep. Please, could you also share your LinkedIn social, so it's going to be very easy for them to reach out to you right there. Also, if you've not joined our WhatsApp group, please join our WhatsApp group, because that's where we're going to be updating you on other upcoming session. And with this opportunity, I'm actually going to be introducing to you that next year, which is 2026, we're going to be having our first also in real life meetup from the Cloud Native Lagos community. And this time around, we're actually going to be talking about um, the things relating to building reliable systems for the future. So everything that has to do with reliability, performance, scalability, and security. We are going to be touching on all of those in this session. So you're going to be getting more info. So please join the WhatsApp group. I'm going to be dropping the link right now. And don't forget to also follow us on LinkedIn. Please, if you've gained something very important from this session, please share on our LinkedIn page. Also tag us and also tag the speakers, because obviously I'm sure that you've worked out from here with valuable lessons, right? One of the lessons I'm going to say is I've picked out is when it comes to security, right? So you can have your cluster still up, right? It's going to be running, but it's just a matter of time, and everything is going to come crashing when someone remembers to poke into your infrastructure. So you don't want that to happen, right? So you also want to keep to date, all right? And make sure that whatever you're doing, you can see right here, we have practical examples, practical use cases, and you know the person to go right to, right? So Sudeep has been able to give us valuable lessons, valuable demos, and everything. Also with Peterson. And with that, I just want to say thank you so much. I'm going to be dropping the link to the WhatsApp group right now, and also the link to our social, right? So, um, with that, I want to say thank you for joining us today. And it's been an amazing session tonight. And I look forward to seeing your feedbacks on our social. And thank you for joining us. Thank you for joining us, Sudeep. Thank you for joining us, Peterson. And also our our guest from Senegal. I can't really recall the name, but thank you so much for joining us today from India. I can see that Tim joined us, so thank you so much for joining us, and we really appreciate you being with us here today. So, good night, everyone. Enjoy the rest of your weekend, and Merry Christmas in advance to everyone, and Happy New Year in advance. Bye.
Bye, everyone.
Bye, everyone.
Happy holidays.